Polynomials, Chapter 2, Part 4, Zeros and Coefficients. In today's video, we are going to see the relationship between the zeros as well as the coefficients of the given polynomial. We will start with linear polynomial. Usually, linear polynomial is represented as ax plus b, where a and b are coefficients. And the zero, the value of x is said to be minus b by a. This x value is said to be a 0 of the given polynomial, and you can see it is directly based upon the coefficients of the polynomial. This quadratic polynomial. We know the quadratic polynomial is given in this form, and it can be expressed as its factors x minus alpha and x minus beta, and the term k can be any constant, and alpha and beta are said to be the zeros of the given polynomial. Now you are going to solve it, and while comparing both the sides, we find the value of k to be a and b to be the value of this, and c to be equivalent to k into alpha into beta. On solving it, we can find the sum of the zeros to be minus b by a and the product of the zeros to be c by a. You can see from this both equations, these both values, that the zeros are linked or based upon the coefficients of the given polynomial. We will understand quadratic polynomial with an example here. So this is the quadratic polynomial. We are going to take 2 as the common, and on solving we get this particular form. And here I said the k can have any values like real numbers. Here it is going to be 2, and we get the factors as x minus 1 and x minus 3. Now the alpha is 1 and beta is 3. We are going to verify the sum of the zeros is said to be equivalent to minus b by a, though we have to take the coefficients from the given quadratic polynomial, that is minus 8 and it is going to be 2, and solving we get both the sides to be equivalent, right side and left side. Similarly, for product of the zeros, we are going to check, we are going to enter the values of alpha and beta, and we are also going to check with the c by a. That value is 6 divided by 2. We get both the sides to be equal, as 3 is equal to 3. And so finally we can write the quadratic equation in this form also, the sum of this zeros and the product of the zeros. Now we will see the cubic polynomial. Cubic polynomial, here we are going to have 3 zeros at the max. So that will be alpha, beta and gamma. These are going to be the factors on solving that particular cubic equation. And so the sum of this particular zeros is said to be minus b by a, and the product is said to be minus d by a, and alpha beta plus beta gamma and gamma alpha is equal to c by a. Here also you can find the given cubic polynomial is based upon the coefficients of the equation given. The zeros of the polynomial can be expressed in terms of algebraic identities also. So here are the few algebraic identities, that is algebraic formula a plus b the whole square, and here you can see few of the examples that I have given. Alpha inverse can be written as 1 divided by alpha plus 1 divided by beta, and on solving you get this equation. Similarly, just go through the values of this. You are going to use a simple algebraic identities that you have learnt in the previous classes, and on solving you will get these forms. We will understand how to use those algebraic identities if the question is given in this format. So this is the quadratic equation. You are going to take the values of this coefficients, and also you are going to find the sum of the zeros and the product of the zeros, that is alpha plus beta and alpha into beta in terms of its coefficients, and on solving you get this. Here you can see I have applied that algebraic identity to find the answer, and similarly for the next one, by simply solving it you can find the answer as minus 5. We have completed chapter 2 polynomials.